one is this? Ready? Okay, hello, Ms. Walker. This is 6-3. We're going to be dividing polynomials. And I have Taylor with me today. Hey, T.
Hey.
And Gerald, of course. Okay, I'm going to get these notes on real quick. I'm going to try to make this a 5-minute video. This is for the ones that was absent who need notes. So I'm not going to really go through it. I'm going to show you so you can pause it and you can read for yourself. And I'll add on to it later because it's 7 o'clock in the morning, and I suppose I gave you this last night. I did not, sorry. So this is what we did in class yesterday. We started off simple. We had a basic problem like this, and we put it over its own denominator. And I'm going to keep my hands out the way. You told me to keep my hands out the way in the last video. Matter of fact, I hope I'm not even in it. I don't need to be. Let me just explain a little bit. I just wanted to post it up. Boom, you freeze it and you copy it down. But you notice right here, I put everything over its own denominator. And then right here, we're just going to simplify it. I'm bringing the variable with the smallest exponent up. This is x to the first. I'm bringing it up. And I'm just subtracting. Whatever the sign is, the exponent is down here, when you bring it up, you change the sign. So on all of these, I just brought it up and I subtract 3 minus 1. That's going to give me my x squared. Right here, I brought it up, so it gives me y raised to the 2 minus 1. That's going to give me y to the first. And then I simplify 4 over 4, which gives me 1. And then I end up still simplifying this also over here. That gives me x squared y. Why I'm just showing you one little term is because you do the same with the other two.
Why?
And this is a problem. Yes.
Why when you bring it down to the final, the final answer, why don't you keep the 1?
Which one? This right?
Yeah. Why you don't keep the 1?
It's understood. It's understood to be a 1 in front of there. You know that, T. Moving along. You have x to the 0 power. X to the 0 power equals 1. So I just did an extra step here. You don't really have to do that. At this stage, this problem right here, you see x over x, go on and make it 1. But I'm doing just every step on this first slide for you, trying to break it down because I'm not talking much, even though I'm talking a lot, but I'm not talking much. I just want you to follow it. Okay, so pause it. That's enough pause? Okay, I'm gonna put the next slide up. Like I said, I'm not explaining this. It's 7 in the morning. I have a workshop to go to. I just want the people who was absent to see what we did in class. This was the next slide that we did. I just gave them an extra example. It's the same problem that was on the first slide. I tried to go step by step, breaking it down again so you can see, bringing things up, okay? And then from here, simplifying, simplifying, simplifying. And then even from here, simplifying some more. They wanted another problem done. So in blue, here's another problem. And it's the same thing. And then I hope you can read this. I'm simplifying from here. Simplifying, and even taking it further because I'm getting rid of my zeros. So you got enough time to pause that and read over it. That's enough time to pause and read it, correct? And this was slide 3. The reason I put this one up, and I didn't even finish working this one out for them in class because we flowed on these. The reason I put this one up is because of this -1. It was raised to the -1. And so like the previous 3 problems that I had up before this one in their textbook look a little different. I told them to go on and rewrite it so it can look like the problem they just got finished doing. And then you're going to do the same thing that you did in the previous slide 1 and slide 2. You're going to take these and you're going to separate them and put it over its own denominator, which is going to be 4CD to the F. And then I gave them another problem that's in their book also, which was this one. You're going to do the same thing, bring this down, it's negative. When you bring it down, of course, it's positive, same here. When you bring it down, it's positive. And then you're going to do the same thing again. You're going to put it over, well, right here you need to simplify this exponent. It's raised to the second, so don't forget to multiply every exponent in the inside. 3 to the second, x to the second, y to the second. Then you could go on and take this problem. After you simplify 3 squared, you could go on and take this problem and put it over its own denominator. Okay. The last slide that we did was long division. And I might need to do, here, copy this down right quick. And I'm going to do this top problem over for you from scratch, just so you can see and understand it a little bit better. So one of these I will just start it from the beginning because you might need a. And like I said, this is for the people who's home. I wrote you a note. You're home on a little vacation for whatever reason, and this is what we did in class. And we did some problems on the board, but you missed out on that. I'm just going to do that first one over so you can have a quick idea of a little explanation of how we did that. Okay, you should have this. You have z squared plus 2z minus 24 divided by z minus 4. We're going to divide z minus 4 into z squared plus 2z minus 24. We're looking at this first term right here, which is our z. We're going to put z into z squared. What time what using this z will give us z squared?
Z.
Z. That's how I got that z at the top. Whatever I put at the top here, I must multiply it times everything on the outside here. Whatever I put at the top here, I must multiply it times everything at the top here. So I have z times z, which gives me z squared. I have z times, Taylor, you need to get over here. This is the part you missed. And if you don't understand something I'm saying, then you can ask and maybe they don't understand, but this is the part you fell asleep on.
Okay.
So that's why she's here now. Makeup. Okay, you know how I got this z right here? I said, what time? I looked at this z squared, okay? And I said, what time what gives me this z squared using this z? Okay, right, z. And then I said, whatever I put on top here, I must multiply it with everything on the outside here. So z times z gives me z squared. Z times negative 4 gives me what? Negative 4z.
Oh,
All right?
yeah.
Now, just like a regular division problem, I'm going to have to now subtract. That's what I did next. I subtract, okay? Now, remember, this minus sign is going for every single thing, or negative is going for every single thing. So I'm not going to just take this negative and multiply it times this positive z squared. I'm going to take this negative and multiply it times this negative 4z also, okay? So you got to remember it's here. I'm not going to change my problem here to remind me. It's out here, it's in red. Remember, this goes for every term, all right? So z squared minus z squared is 0. 2z what?
Minus 4z
But this is actually what?
plus 4z.
Exactly. So 2z plus 4z is
6.
6z. Now I'm going to bring down this negative 24. All right? Now we'll start all over again. I'm going to do the exact same thing that I did to get this z squared. Looking at that z, I'm going to say what times what gives me 6z using this z.
6.
It's going to be a positive 6. Okay?
Now with the positive 6, you don't add the
Because
z in front
I'm
of it.
multiplying it.
But I'm saying, like, when you ask, like, what z gives you this 6z, like, you don't add the z after the 6 when you put it on top.
No, because 6 times z gives me 6z.
Oh, okay.
See, I'm multiplying it also. Okay, to get that. Okay, so 6 times z gives me 6z. And what did I say about what goes on the top here? Do you remember?
Goes on the bottom.
I have to multiply it times everything. Okay? Whatever's on the top is multiplied by everything on the side. Okay? Remember that. So 6 times z gives me 6z. 6 times negative 4 gives me a negative 24. Now I'm going to do what? What you think?
Simplify.
I'm going to subtract. All right? So I'm going to subtract. All right? And I'm not just going to subtract what? This just, and the reason I put it in red, and of course you use some pencil, circle it so you'll know that this is not a negative 6. Okay? This minus, you're subtracting the whole thing. So I have 6z minus 6z, that gives me 0. And I have negative 24 plus 24, that gives me 0. So my remainder is 0. That's how I got this right here. Alrighty. And the last problem that I did, okay. Well, the last problem I did, it had a remainder, but I'm going to leave it at this because I'm running out of time, and I'll see you later on to continue 6-3. Bye-bye.